They will be focusing on sequences. Sequences are simply defined as a list of numbers. Some sequences have pattern, like arithmetic sequence, which is based on addition or subtraction of a quantity. Metric sequence, which is based on multiplication or division. Number in the sequence is called a term and is denoted by a letter and a subscript. For example, in the arithmetic sequence, we have a sub 1, 1, a sub 2, 3, and so on. In the geometric sequence as well, we have a sub 1, 2, a sub 2, 4, and so on. This type of sequences, the top two in the arithmetic and the geometric, have the beginning and the end. So it has a beginning and the end. These are called finite sequences. In the arithmetic sequence, the pattern is based on addition. On the left side, top sequence, 1 plus 2 generates 3, 3 plus 2, 5, 5 plus 2, 7, and so on. That quantity is called a common difference, or D. In the geometric sequence, the pattern is based on multiplication or division. Here is 2 times 2, 4, 4 times 2, 8, and 8 times 2, 16. That common quantity is called a common ratio. Common ratio, 2. This 2 here. The bottom two sequences in the arithmetic side starts with a sub 115, but there is no end. Ends in ... meaning continues into the infinity. This type of sequence, these types of sequences are called infinite sequence. In the geometric side, we have another example of starting off with 1 and ending ... infinite sequence. The pattern in here, in the geometric, 81 times 1 over 3, or divide by 3, 27, 27 divided by 3, 9, 9 divided by 3, 3, and so on. The common ratio in the geometric side is 1 over 3. In the arithmetic side, we have a subtraction, 15 minus 3, 12. 12 minus 3, 9, and so on. So D, or common difference, is minus 3. In order a sequence to be arithmetic, a sub 2 minus a sub 1 must equal a sub 3 minus a sub 2 must equal ... So the difference of consecutive two adjacent terms must stay the same. The top sequence was 2, bottom sequence minus 3. In the geometric side, a sub 2 over a sub 1 must equal a sub 3 over a sub 2 must equal ... So the ratio of two adjacent terms must stay the same along the sequence. To find any term in the sequence for geometric or arithmetic sequence, let's say what is called, one way is to use the general or explicit formula, where the a sub n, any term, equals a sub 1 plus n minus 1, the position, times d, common difference. Also, any term can be found in geometric sequence using the general or explicit formula, where a sub n equals a sub 1 times r to the n minus 1. There's another way to find a term, which is based on having the immediate previous term. Arithmetic sequence a sub n equals a sub n minus 1. Immediate term close to adjacent to the next one, plus what the common difference is, d. In the geometric, a sub n equals a sub 1, a sub n minus 1, times r, a common ratio. Let's start with some practice problem. I would recommend you to pause the video, do it yourself, and then unpause to check what you did. Please, that's the best learning practice. Which of the following is arithmetic or geometric sequence? A. Which one is finite and which one is infinite? So going from 2 to 4, we add 2 in A of them. Going from 4 to 6, adding another 2, another 2. So it continues. The only difference is the top sequence has the beginning and has the end. The bottom one has the beginning but no end. It ends in ... So both of them are based on addition, adding quantity. So they are arithmetic. The top sequence is finite. The bottom sequence is infinite and ending in ... How about the C and D? C, we have the beginning. 1, but we have no end, ending in ... How about the pattern? 1 times 3, 3 times 3, 9, 9 times 3, 27. So it is a geometric based on multiplication, and it is a finite, is an infinite sequence since it's ending in ... How about the bottom sequence, D? Let's look at the pattern. 2 times 4, 8. 8 times 4, 32. Times 4, 128. Has a beginning, has an end. So is based on multiplication, is geometric, and is finite. The next question. Consider the following sequences. Which one is arithmetic and which one is geometric? To be arithmetic, a sub 2 minus a sub 1 must equal a sub 3 minus a sub 2 must equal ... So 4 minus 1 equals 3, 7 minus 4 equals 3, and continues. So we have it. Here we have the arithmetic sequence, and D equals 3. D equals 3. How about the other side? We have the a sub 1, 2, and a sub 4, 16. A sub 2 and 16. Do we see any pattern? What is the pattern? 2 times 2, 4. 4 times 2, 8. 8 times 2, 1. So it's based on multiplication. We know it's a geometric. And where R is equals 2. Remember, we applied a sub 2 divided by a sub 1 equals a sub 3 divided by a sub 2 equals ... That is still applies in the geometric side, meaning 4 divided by 2 equals 2, 8 divided by 4 equals 2. So that applies as a geometric sequence, and r equals 2. Next, find the next two terms. So we have the common difference in the arithmetic side. All we have to do, add another 3. So 10 plus 3, 13. 13 plus 3, 16. Next two term. How about the geometric? It's based on multiplication, and r is 2. The next two term, 16 times 2, 32. 32 times 2, 64. The next two part is asking to find the general formula and the recursive formula for arithmetic sequence a sub n equals a sub 1. What is it? 1 plus n minus 1 times d. What is d? 3. All right, simplify it and add the like term. A sub n equals 1 plus 3n minus 3 equals 3n minus 2. How about the recursive formula? This is general formula. Recursive formula, a sub n equals a sub n minus 1 plus d, which is 3. Let's look at the geometric sequence. We have r equals 2. So a sub n equals a sub 1, which is 2, times r, which is 2, to the n minus 1. How about the recursive formula? A sub n equals a sub n 1 times 2, which is r.